All right, so moving on to our third solvent extraction. This one's probably going to be the most interesting because we're actually going to separate a mixture of compounds based on the compound's acid-base properties. So here's our three compounds. We've got benzoic acid, which we've previously used. We've got our ethyl 4-amino benzoate. And then we've got our 9-fluorinone. And so if we take a look at our compounds, we can see different properties. In this benzoic acid, we've got a carboxylic acid. And so we're just going to arbitrarily call this orange. Over here in our ethyl amino benzoate, we've got this amine right here, which is basic. And then finally, in our fluorinone, we have no acidic or basic components to this compound. And so we've got a compound that's an acid, a compound that's a base, and a compound that's neutral. And so the first thing that we're going to do is we're going to dissolve this in ether. And mix in a layer of water. And so in this case, our ether layer will be up top, and then our water layer will be down on bottom. And these three compounds in their neutral state will generally prefer to go in the ether layer, so we'll have all three of them in our ether layer. And now we're going to start separating them based on their acid-base properties. So the first thing we're going to do is we're going to add some hydrochloric acid to this, and we can think about which one of these compounds is going to react with an acid. Well, it's going to be the basic component. So the reaction that we're going to see here, I'm just going to draw the amine part. Right, this can act as a base. We have some acid, some H plus added here. And so we formed an ion, right? And so if we formed an ion, it's probably going to go into the aqueous layer because it's now ionic. And then we can simply separate out the two layers. And so now down here in our water layer, our acid is, or our base is down here. And in our ether layer, the other two compounds remain. And so now that we have this in our water layer, what we can do is add some base to this. This will deprotonate this compound, return it to a neutral compound, and reduce the solubility in water. And so what we should see is a precipitate coming out. And then we can filter and collect that precipitate. And so now we've isolated the basic component. Then back to our ether layer, we can add some sodium hydroxide. If we think about which one of these compounds is going to react with the sodium hydroxide, it's going to be the acidic component. So we've got our benzoic acid, just going to draw the carboxylic acid component. And then we've got our hydroxide. Coming in to deprotonate, and we can see again we've formed an ionic compound. And that's going to go ahead and go into our aqueous layer. So again, we're going to separate out these two layers. And now our acidic component has moved into our water, and our neutral component is still in our ether. And now to get these components out for the water layer, what we can do is add some HCl. This will return it to its neutral form, and thus it won't be as soluble in the water, and so we should get a precipitate coming out, and we can filter to isolate that. And then finally in our ether layer, ether has a very low boiling point, and so we can just evaporate this off using a flow of nitrogen. And then we will be left with a solid precipitate there. So you can see how we start off with a mixture of three components, and using some acid-base chemistry and solvent extractions, we can isolate our three components based on their acid-base properties. All right, so here we have our 15 ml centrifuge vial with a little cork cap on it. And we're going to hold this inside of a beaker because obviously it's going to go all over the place if you just try to set it on the table. And we're going to weigh out our solid. So we'll take our piece of filter paper, fold it in half. Put it on the scale. Tare it. And so first thing we're going to weigh out is 50 milligrams of our benzoic acid. So you can see here it comes in these kind of little white solid chips. Remember, this doesn't have to be exact. There's that. Go ahead, take it out and put it in our vial. You see when you fold the filter paper, it's quite easy to just pour it in here. Toss away this filter paper. Cork this, put it back. Get a separate piece of filter paper, fold it in half. On the scale. That's actually pretty close, huh? Tare. Next up, we're going to add our ethyl 4-amino benzoate, our base. You can see this kind of looks like table salt, much more granular, white, crystalline powder. Weigh out about 50 milligrams. There's that. Go ahead and put that in our vial. Crumple this up and toss it away. And then finally we have our 9 fluorine own. Okay, the main thing to remember about this is not actually any fluorine in here, which is a little odd, but whatever. You can see it's similar to the previous compound in that it's kind of crystalline and kind of salt-like, but this time it's obviously yellow, which is kind of cool. Another piece of filter paper. Tare it, and then let's measure out about 50 milligrams. And in here it goes. All right, now we got all of our solids in here. All right, so we've got our mixture of solids right here. Next thing we're going to do is add 4 milliliters of diethyl ether, which I have in this secondary container here. And we use it to measure out our graduated cylinder, right? It doesn't have to be exactly 4 mils. And there's about 4 mils. I'm going to transfer that over. And then use our glass stirring rod here to just mix it up until it's fully dissolved. And so now you can see we have a clear solution indicating that it's fully dissolved. All right, next up we're going to cool our solution in an ice bath. So you can see in here I have some ice and just some regular water. And then you just put your solution in there and let it sit there for a few minutes. All right, so next up we're going to make our calibrated pipette. So I've got a little pipette with a bulb here. I've got a little beaker and then my graduated cylinder and then a marking pencil. So I'm just going to take some distilled water and pour 2 mils of it into my graduated cylinder. So we've got about 2 mils there. Pour it into this beaker just so I can get it into my pipette. And so about the capacity of this bulb is right about 2 mils, and so you're really going to have to maximize the whole capacity. So you really want to give the bulb a good squeeze and try to squeeze all of the air out of it that you can. Stick your pipette in your water, and then go ahead and suck up all 2 mils. And so you can see there's a little bit left in here, so I didn't quite squeeze my pipette bulb enough. A little drip of water, but that's okay. All right, I got pretty much all 2 mils up there. And so you can see it's quite about the max capacity of the pipette. Take my marker pen and just mark that line. And then just get rid of this water. And now we know about how much 2 mils is. All right, next up we're just going to grab some 3 molar hydrochloric acid. And so obviously it's in the secondary container. And then we're just going to pour out a little bit for our beaker to work in our workstation. Should be more than enough. All right, so we've got our solution on ice. We've got our HCl over here, so I'm going to pipe it out 2 mils. A little bit below our calibration mark, but not too bad. I'm just going to go ahead and pour it into this clean beaker as well. That way I can just pour out as I want. But you don't have to do that. Take our solution out of the ice bath. Take the cap off. And then we're just going to slowly add dropwise our HCl into our ether solution. You can see it's forming 2 layers. And give it a good stir every now and then. Don't slam the bottom with your glass stir rod because you will break the glass. So be gentle with this. Add some more HCl. I'm just going to add a tiny bit more of HCl just because we're a little bit under the calibration mark. Doesn't really matter. Give this a good stir. And we can go ahead and cap it and then use our Vortex Mixer to give this a good stir as well. All right, so here we have our Vortex Mixer, right? So it's this little top here, and anytime you put anything here, it's just gonna mix it. You just gotta apply some pressure. And so what you wanna do here is hold your vial pretty firmly, and then you wanna press down firmly. If you don't press down firmly, it's gonna shoot your liquid up to the top and get all over the cork. You can see that already happened to me a little bit, but okay, that's fine. So just press down and hold firmly. And you can see now it's not going up to the cork. Just try to zoom in on this action. You can see it looks like one layer and then it slowly separates into two. Cool. All right, next up we're going to use our pasture filter pipette to get out the bottom aqueous layer and put it in this little 10 mil Erlenmeyer. Go ahead, uncap it. Remember, squeeze before you get into the liquid. Submerge, and then let go. And you can see the cotton really helps slow down this uptake, which gives you a lot more control versus an unfiltered pipette. And pull this part out and then get the next little bit in another trial. Transfer that over. And then pick up the rest of it. So squeeze when we're outside. Submerge, and then let go. Just squeeze the rest of this liquid out, and then I'll pick up the last bit in the last go. See, I probably packed the cotton a little bit too much, but that's okay. It'll make our experiment go a little bit smoother, just a little bit slower is all. All right, let's get the last bit of this aqueous layer. I'll leave a little bit of the aqueous layer, just a tiny amount left, because we're going to fill this up with more HCl. All right, we're just going to repeat this step, grab another 2 mils of HCl. A little bit below, that's okay, we'll just add a little bit more. Give it a little stir. Let's grab a tiny bit more of the HCl. And then we can vortex mix this for several minutes. I'll do that off screen. All right, so you can see I've off screen vortex this. So now we're going to grab this aqueous layer and combine it with our previous aqueous layer. Again, I've got a new filter pipette. So squeeze when we're outside. Put it inside the liquid, down to the aqueous layer, and then let go. You can see we're going much faster this time. I made a better filter pipette. And the main thing that I did to kind of make it better was basically just add less cotton. 9 times out of 10, you're going to add too much cotton. And then let's just go ahead and get out the rest of this aqueous layer. And now we have our aqueous layer. You can tell it actually has a slight yellow tint to it, which is probably not what we wanted. It indicates that we probably got some ether in here, because the yellow compound is the fluorinone. But we'll continue on and see what happens. All right, so we've got our acid solution here in the center. Off to the side here, I have some 3 molar sodium hydroxide, and so we're going to add the base to the acid until it turns basic to litmus, right? So we've got this red litmus paper that will tell us when it's basic enough. So here you are adding a base to an acid, so clearly you want to do this carefully. And so just start off slow and dropwise. And you can see as soon as we add the drop, we start seeing some precipitation if you watch closely. See, every time I add a drop, we see kind of a cloudy precipitate. probably not enough, but let's check out the litmus paper anyway. All right, you can see it didn't turn blue, so we still need to keep adding base. And if you can feel this Erlenmeyer, it is actually warm to the touch. You can see our precipitate is starting to stay now. It indicates we're getting more and more basic. You can see it's very cloudy. And you can see we've turned blue to litmus paper. So I'll just go ahead and put this on an ice bath and let it sit for 10 to 15 minutes while we set up our filtration apparatus. Cap it up so no ice gets in there. All right, so before we start making our filtration apparatus, we're going to get some filter paper and weigh it on our watch glass. That way we know the mass, and that way we can have the kind of empty and full with product and subtract the two to get the mass. So put the watch glass on there. We'll take a piece of filter paper, these little tiny ones. The filter paper, put it on here, and now we'll get the empty mass, and then we can subtract this from our mass with the compound to get the mass of the compound. Alright, so next up we're going to set up our filtration apparatus. I've got a ring stand back here. We'll go ahead and put one of these big clamps about this level. And then we're going to put our trap and clamp it on here. Then you're going to attach the end of the trap into the vacuum line. Then above this, we're going to put our Hersh funnel. So you see we've got a Hersh funnel with our sidearm Erlenmeyer. So you just attach these two and give a little press to seal it in there. Put the small clamp up here. Clamp that securely in place, and then connect the trap to the Hersh funnel using some rubber tubing. And then you can go ahead and turn on the vacuum and just test your system, make sure that it's nice and tight and that you're getting good suction out the top. So this is a little switch that you can turn off the vacuum. And it sounds like all the suckage is coming through our Hersh funnel, so that's good. Cool. So we got our Hersh funnel up here. First thing we're going to do is add our filter paper. Make sure it's covering up all the holes. You want to go ahead and turn on the vacuum And then close it up over here. And then you're going to want to go ahead and just wet the filter paper with whatever you're pouring through. So in this case, it's deionized water. So I'll just pour a little bit of deionized water just to get this filter paper to kind of stick onto this funnel. And so that way it won't fly away when we pour our solid in here. So we've got our compound in here. Open it up, give it a little swirl, and then a quick solid pour. And then we want to rinse out our beaker and our solid precipitate with 2 1 ml portions of water. I'm just going to guesstimate this. And then just wash our top solid with some more DI water. And then we'll just go ahead and let it sit here and air dry for a few minutes. All right, so at this point we're going to repeat essentially the same procedure as before, except instead of HCl in here, I have sodium hydroxide. So we're going to pour 2 mils into here, mix it up a bit, take out the aqueous layer, add another 2 mils, mix it up a bit, take out the aqueous layer. Let's go ahead and add our initial 2 mils. Then we're actually going to add just a tiny bit more of ether into here. Give this a good stir. And then we can vortex it as well. So again, here's our vortex mixture this time. We're going to really make sure to hold firmly and then press down quite a bit, and that'll keep the liquid from shooting up and contaminating our cork. So let's see how this goes. I'll hold down here, that way you can see if it's hitting the cork or not. And you can see when I press down firmly, it doesn't go up to the cork. So, a bit of a technique improvement there. And then I'll just do this for several minutes. All right, so now we're going to use our pass-through filter pipette to go ahead and extract this bottom layer right here. And you can see I've labeled my beaker here, acidic component. And then off screen, I'm just going to go ahead and repeat this procedure one more time. All right, so now we're going to wash our organic layer. So to do this, we're going to add about 1 ml of deionized water to this. So I got my DI water right here. It's about 1 ml. Go ahead, toss that in there. Give it a good stir. Use your filter pipette to go ahead and remove the aqueous layer. Put it in this little beaker that I've labeled wash. And then here's the trick. You really want to expel this slowly. Otherwise, you're going to shoot the cotton ball out, which is what I've done previously. And so a bit of an error. So with these filter pipettes, the key is really to have some patience and go slow. And we'll go ahead and repeat the procedure again. Add 1 ml of water. Give it a good stir. Some time for the layers to separate. And then go ahead and extract out the bottom aqueous layer using your filter pipettes. Last bit with another filter pipette. And then to our ether, we're going to add some sodium sulfate. So I have 300 milligrams of sodium sulfate right here. Just going to pour this in. And allow this to dry for several minutes while we work on our acidic component. So I'll just put the cap back on and just let it dry. All right, so we have our acidic component over here. And then I've got some 6 molar HCl. We're going to add it into there until we see, or until we're acidic to litmus, and we should see the formation of some kind of precipitate here. Let's go ahead and check this out. see if it's basic or acidic enough. If it is, it should turn this paper red. Right, still not acidic enough. You can see we've got a good bit of precipitate, so it's probably done. Yep, and red. And so now we'll just go ahead and put this in an ice bath after we cap it. Put this in an ice bath and let this hang out there for about 10 to 15 minutes. All right, so our acidic component has been in the ice bath for at least 10 minutes. You can see we've got some nice precipitate there. And so we're going to go ahead and filter this through. So we've already pre-weighed our filter paper on our watch glass, so we'll go ahead and take the filter paper, put it on our Hersh funnel, make sure you cover up all the little holes. Turn your vacuum up over here. And then close this valve over here. And now we've got a good suction going. Going to go ahead and wet our filter paper with whatever we're pouring through, in this case just some water. And we're going to take our solid and filter it through. Pour a little bit slowly because last time we saw the filter kind of got clogged a bit when there was a lot of liquid in here. And pour a little bit extra water in here. You can see there's still a bunch of solid left on the sidewalls here. So just try to pour some water in there, get it to come off. You can use your micro spatula to scrape off these sides and kind of get it into the water. Give it a good swirl to get the water to pick up all the solid. And then you want to kind of get a nice smooth transfer. And then just do that one more time. And go ahead and filter this wash through. And then in our case, we'll just let this sit on the vacuum for a couple minutes to dry. All right, so at this point, our ether layer should be nice and dry, so we'll go ahead and use our pass-through filter pipette to transfer the ether layer over into this pre-tiered 10 mil Erlenmeyer. So what we want to do is get all the ether out without transferring any of the solid sodium sulfate. All right, that's pretty much all the liquid that's in there. Pretty much all that's left here is sodium sulfate. All right, so we've got our ether here that I've gone ahead and added the boiling chip to, so don't forget to add that mass in there. Unscrew it, place it in our hot bath, or our warm sand bath. And then we're going to stream some nitrogen over it to evaporate off the ether. You can see we're left with this yellow solid. Gonna let it dry for a little bit longer. You can actually tell it's actually pretty nice. Look at those little crystals. Not too bad.